Hello everyone. So today we will discuss one question from the topic decision tree. Okay. So this is a standard question given in this NPTEL course Introduction to Machine Learning. This is a question from week 6. So it's a very good example. What is the question? So consider a data set with one attribute which is categorical, and suppose there are 10 unordered values in this attribute. Okay, how many possible combinations are needed to find the best split for building the decision tree classifier? So the data set, if we try to visualize the data set is having only one attribute. That means only one feature value is there, or only one attribute attribute is there, and there can be another one, that is the target feature. Okay, that is the target feature which we generally denote as y, and the feature we generally denote as x. Now it is telling that it is having only one attribute value, and all the attribute values are what? They are categorical values. Categorical values means it may be a, b, c, something like that, or it may be red, blue, green, something like that, yes, no, this kind of values. Okay, and how many such attribute values are there? There are 10 such attribute values. So total number of rows here is 10, and they are saying that all these are unordered. Okay, there is no order followed. How many possible combinations are needed to find the best split point for building the decision tree classifier? Okay, so when we build a decision tree, the feature or the attribute we take as the root node, right? Since there is only one feature value, that will be the sole root node here. Okay, now based on the feature value, I will decide like how many generally in decision tree will consider as two split only. Okay, it's a binary split. So here, based on this attribute value, we are going to split the data. Which data? This root x, it will contain all the attribute values, right? All the attribute values which may belong to any kind of class. There can be a positive class, there can be a negative class, again a positive class. Okay, so there is no information regarding the y value, but ultimately we know that the y value may contain the class level. There can be positive, negative, or there can be class 1, class 2, class 3, something like that. Okay, now here the class level will be obtained from the final leaf nodes. Okay, but before that we need to split the root node, right? We need to split the root node. So in how many possible ways we can split the root node? Okay, so as we can see that for this binary splitting, we can have two types of two number of values here. For example, the splitting can be like here only one attribute value can be there. Okay, only one attribute value, one categorical attribute value, and all rest of the attribute value may belong to the other set. How I am splitting it? Here the question is asking how many possible such combinations. So one combination is what? 9, because total is 10. Another combination that is that in left hand side of the of this edge may contain two number of attribute values. Then in the right hand side of this edge, it will contain 8 number of attribute values. Okay, so if we try to generalize it, how many values are there? There are 10 values. So out of these 10 values means if I need to divide this 10 value into two set, if I need to divide this 10 value into two set, how many possible such combinations will be there? The combinations can be that in one set it will be totally empty, and the other set it will have 10 such number of values. Okay, The second possibility is that one set will be having one attribute value, the other will have then 10 minus 1, that is 9 attribute value. So another is 2, 8. Okay, these kind of possibilities are there. And finally, how many we can have? I can have now 10 here and 0 here. Okay, so if we generalize this particular problem here, what we can do, suppose this 10 attribute value I am considering random value, suppose it is a p value. Okay, how many attribute values are there? P attribute values are there. So the splitting will also be done like in one set there will be 0, okay, and in the other set there will be p. Yes, in one set there will be 1 if it is, then the other set will have p minus 1, 2, then p minus 2. So likewise it will be finally in one set there will be p and the other set will be having 0. But here as we can see that this we can also represent as what? We can represent it as PC naught. Okay, PC naught, what is the final value of PC naught? That is nothing but 1 only, right? So it will be if it is PC naught, P, then P minus 0, 1 value and then 0. Yes, and it is equal to factorial of P divided by factorial of P again, it will cancel out and finally it is 1. Yes, similarly the second combination I can write as PC1. Okay, the third combination I can write as PC2. So likewise the last combination I can write as what? PCP. Okay, and this PCP, this one is also, the last one is also factorial P, it will be factorial P and factorial P minus P, which is finally equal to factorial P by factorial P, it will be cancelling out and 1. Okay, the first and the last value, those will give me 1, right? So from this particular finally what I got, how many combinations will be there? These are the possible combinations, right? These are the possible PC1. For example, here out of 10, 1 will be in one side and the rest P minus 9, P minus 1, that is 9 will be on the other side. So each time out of 10 1 will be on one side, rest 9 will be 9. So each and every element of that 10 values will get a chance to be in one set. Okay, in that way we can calculate as PC1. Okay, now from binomial theory, this summation we can write as what? What is the summation? The summation is PC naught plus PC1 plus PC2 up to the last term will be PCP, right? And before the last term it will be what? PCP minus 1. Yes, from binomial theory, if we add all these values, it will be 2 to the power p. Okay, it will be 2 to the power p. But now we can for this particular decision tree problem, we can again try to customize our solution, right? For example, here if one of the set is empty, another is full, okay, then that combination will not work for us. Okay, so for our solution for a decision tree, that combination value will be what? 2 to the power p. So there is one set where it will be totally empty, other will be totally full. Then in the last option also, here this one on the left hand side set, that is totally full and the right hand side set will be empty. So these two options we need to ignore. Okay, so for this decision tree, this formula will now modified with as 2 to the power p minus 2, because ultimately these two value when we have calculated, this comes as 1 and this comes as 1, right? So I am just subtracting these two. Okay, then another thing that we can see here, from these combinations, these PC1 and P minus 1, these two are also technically same only. Yes, similarly PC2 and the previous term, previous second last term, not third last term, these two will also be same. Okay, so out of whatever values are there, two of those will be same. It will give me the same combinations PC1 and P minus 1. So that if I consider all the combination of PC1 and all the combination of P minus 1, they will be redundant. Okay, I need to find out only the unique set of the split. Okay, so the redundant one only, redundant sets we will again ignore. So for our decision tree, finally what we can conclude it, out of all two sets will be there which will be same. Okay, so ultimately I have to divide it by 2 so that I can have only the unique one. Okay, so that's why I am dividing it again by 2, equal to what? It will be 2 to the power p minus 1 minus 2 divided by 2 will be 1. Yes, so final generalized value for these p number of or unordered values in a attribute, this combination is 2 to the power p minus 1 minus 1, and we are given this p value as what? 10, right? So it will be 2 to the power 10 minus 1 minus 1, which is equal to 2 to the power 9 minus 1, which is equal to nothing but 511. Okay, so the option 2, that is the correct option. Okay, if you have any doubt regarding this question, you can ask your doubt in the comment section. So thank you everyone.